Any questions you guys can think of? Yeah, I can think of some more things. There's going to come a time, and I don't know if I said this already, but it's good to remind you guys that we will need laptops in this class. After we finish the test next week, we're going to do a section on 1.6. It's just one day, 1.6. And then that Friday, the 15th, we will be on our computers, our iPads, whatever you have, not our phones, doing an assignment in College Board, okay? Not for a grade, just for completion, kind of like homework. But I'm just giving you a heads up now that we do use laptops in here. So if there's an issue with you, like I don't have one, I never got one through my English class, my parents won't let me, if there's some issue that you won't be able to have one by next Friday, please let me know. We don't use them every day, but I'll try to announce to you, okay, we're going to be needing that day. And we'll have to come up with a situation. Like if Ty says, I dropped mine and it broke. He and I will have to come up with some way of making that work. So I just expect you guys to talk to me about it before then. And I'll keep reminding you. It's not this Friday, it's next Friday. Okay? All right. And last thing, I think, I'm talking about, don't forget your binders, your business. I'm going to offer extra credit one day this week. The way I do extra credit is I'll call it pink sheet extra credit, okay? Where I simply just say, everybody open to their calculator tip sheet. That's it. And I just give you extra credit, just a quick visual. You have it in your 3-ring binder. Like you can, not like, let me dig it out of my backpack, let me go do this, hole punch. I've already given it to you, hole punch, so you shouldn't have to do that. But it's just extra credit just to remind you guys how important it is to have that stuff with you. If I choose for you guys to show me this, I would expect some circling to be done over here, okay? You can take it seriously or not. I prefer you take it seriously, obviously. But this is, you can read the legend here. I'm not going to go through it. But this is everything we'll be learning. This whole first page is our first test, okay? And we're all the way down to here. So these are all skills you should have learned, all right? So if I choose this as your extra credit, I would expect these to be circled already, not quickly doing it, all right? So just, if you haven't, just take some time at some point, not right now, to do that. Okay, so today's notes are a little bit longer, okay? Tomorrow's a little bit shorter. Just know you have extra time to finish this. If you don't get it done in class today, it won't get checked tomorrow, all right? But first thing I want to tell you about is one of the things we're going to be doing today is learning some really cool things on our graphing calculators. And so that means you have graphing calculator homework. And so when we get to the homework, I'll go through the problem and say, this is a graphing calculator when it says it in the directions. But maybe any time that there's graphing calculator work to do, you do it in class. So you skip to those homework problems so that you can do them in class. Or there are lots and lots of free apps that you can download on your phone. These are just ones that, I have an Apple phone, so I use this one. But if you just go to the App Store and put in Graphing Calculator or TI-84, there's dozens of them. Pick one you like, okay? I don't know a lot about Androids. That one was given to me. I don't even understand that language, whatever. But eventually the county is supposed to give you guys a graphing calculator to keep at home if you want to check one out. It's not required, but of course, if you want to, why not? All right? So until that happens, we have to have another way of doing these at home in case you don't get them done in class. And you can find simulators online, too. You can go on the World Wide Web and look up TI-84 and find one online, too. Okay? So don't feel like you have to buy one. I am going to get you one eventually. Okay, so having said that, let's get started. So she, the lady that does these notes, is a little wordy at times. So just so you know, I spent a lot of time outside of class going through the notes, crossing things out, deciding what order to do it in, pick the homework problems, because I don't need to sit here and do everything. I skip around sometimes. So this is what a polynomial looks like, and it looks like craziness. But let's just zero in on a few parts of that are really, really important. And the first one is degree. Okay, that is the biggest exponent. Degree is the largest exponent in the whole group of terms, okay? And we always put it first in standard form, right? Our exponents are in descending order. We've already talked about that here. So when I talk about the degree, I'm talking about the biggest power that we have, okay? The leading coefficient. Coefficients are just numbers in front of letters. Leading is the line leader. So that's this guy right here. So the number that comes right after the equal sign, you can think of it as. He's hanging out with the degree. And the constant, these are just vocab words. The constant is this a sub 0. It's a number without a letter, like x to the 4th plus 5x minus 7. Negative 7 would be the constant. Constant's just the last number. And these are really important parts of a polynomial that tell us a lot about the polynomial. And we'll be talking about it in the next couple of days. And turning points, we've already talked about turning points. They're like those visual, easy places you can see where increasing changes to decreasing or vice versa, up to down. They're just like the easiest part. That's super visual. You can just look at them and find them, okay? And we're going to be looking at those today. And then the end behavior of a graph, that's like what is happening. Are there arrows going in the same direction, up, up, down, down, or one at each? Are there end points at the end? What's happening at the ends of the graph, okay? And then what we're really focusing on today are something called maxima and minima. You put those two terms together, and they're called extrema. Okay, so that's just a blanket term. So if I talk about the extrema, I'm talking about the mins and the maxes. All right? She gets really wordy in this section, so let me just narrow down for you. And there's something called a local maximum and a local minimum. You can also call it relative maximum or relative minimum. These words are interchangeable. You'll hear me say local or relative. They mean the same thing, okay? And I'll talk about why they're called that after I introduce the other type, which for some dumb reason it's on the other page. So just flip for me real quick. Sorry. There's something called absolute maximum and minimum, also called global, okay? So if you want to just put a note here. Those are interchangeable. Okay, so absolute and global go together, and we'll come back to that, and relative and local. Okay, so I'm going to help you understand those with these pictures. So what we have actually in both of these pictures, we can kind of do them both at the same time. We have two graphs, right? And I think it's pretty easy in both graphs to identify turning points. Okay, there's 3 turning points here and 2 turning points here. They're really visual. Extrema happen at turning points. We're going to have a turning point. Everywhere there's a turning point, you're going to have a min or a max, okay? These two graphs are called open interval graph, meaning there's arrows on the end. We see them on this one, okay? Open interval meaning the x-axis, goes on forever and ever and ever and ever. So it's open. And even though we don't see arrows here, we know they exist. How? Well, because it didn't tell us any different. Remember your quiz that you just took? There was no arrows. There were no even end points on the graph. But in the directions, it told us from -6 to 6. That's considered closed. Okay? So these are considered open intervals. And I'll remind you of it when we get this one. This is a closed interval. It stops. It doesn't keep going. It is telling us it stops. The one on our quiz was a closed interval. And like on the review, all of us did the review, from -6 to 6. Okay, if you didn't get that worksheet because you missed another day, please see me before you leave and I'll give it to you, or you can print it off of Canvas if you forget to ask me. Okay, so if you have a turning point, you have a min or a max. So I didn't really explain it great, I feel like, earlier, because I had someone asking, how do you know when one's a min and one's a max? And it's just really like if you have a concave down, see how this turning point's at the top? That's considered a max, okay? That's a max. So this is a max. You can have more than one, and this is considered a minimum. And what this relative and local business means is it's in our viewing area, relative to what we're looking at. Local, like nearby, close. So, I'm about to sneeze. All of these are considered relative or local mins and maxes, okay? If you're an absolute, meaning like the biggest or the smallest point, also global, think of local is in our neighborhood and global is like you have to fly to get to it, it's far away. You can also be absolute if you're a relative. In other words, if there's no points lower than you or no points higher than you, you could also be considered an absolute or global. So look at this minimum. This minimum has lots of points that are below it, right? These arrows are telling us there's a ton of points below that point. So this is not an absolute minimum. But are there any points above these two? Nope. So these are both also absolute. I'm sorry, squeezing here. So you can be both absolute and relative, okay? And that's kind of different from maybe other times you've been taught. It's different from the way I used to teach it. You were one or the other. But the way, and there's lots of topics in math that different textbook and mathematicians disagree on. This is kind of one of them. But we're going to do what we're doing for this course, which it could be both. And you'll start seeing, by the end of the notes, it's very easy to tell. I don't think anyone's confused about that. All right, so let's look at this graph here. We have 2 turning points, so we have 2 extremas, okay? And so it's asking us to shade increase in green and the interval decrease in red. If you don't have colors, don't worry about it. This is review. This was on our quiz, right? We're increasing in these 2 sections. You could just put like an I next to it to show increase if you're not using colors, totally fine. And then, of course, this is your decrease. And what's in between these intervals is our turning points, right? So I labeled it. Now, let's state the intervals of increase and decrease. Again, this is review, but I think it's important. So increase intervals, we use the x values. And since we have arrows, that's negative infinity, right? All the way to what x value? Where do we stop going up? -1, good. And then we have another interval that's increasing. That would be 2 to, yeah. Now, I used parentheses. You can use brackets. Remember, these are the ones that doesn't matter. But just remember, if you choose to use brackets, which you will see, you'll see it on a multiple choice test, okay? You'll see brackets. But what you won't see is brackets around infinity symbols. You'll never see brackets. So you would see, like, the more proper, like, brackets here and parentheses here. So I'm just lazy. I'm like, just make them all parentheses. And then decreasing, -1 to 2. Again, brackets or parentheses. Okay, so remember, x-axis is how we name those. And now let's talk about what we have going on here. I think you guys would agree that this is a max and this is a min. Anybody want to tell me, are they relative or both? Or is it, so do we all agree that they're relative, right? Because if you can see them, they're local or relative to our viewing area. They're right here. They're relative. Are either of them also absolute or global? No, because these arrows, by definition, mean we're going to keep going. We're going to go right past that point. We're going to go right past that point. So there is no absolute. That's okay. We don't have to have those. All right? So just so you know, the way you would name those, there's 3 different ways. And I'm going to show you all the ways, because it doesn't matter which way you do it for me. I want you guys to be able to recognize it on a multiple choice test, because our tests are going to be very similar to what an AP test looks like. Tons of multiple choice, and then some FRQs, which are just like, you know, short answer kind of thing. And so there's lots of multiple choice questions where they might label it like this. The mins and max, if I just say what is the min or what is the max, if you're going to just give me the simplest answer, it's the y value. So this is 6. It hits the highest y value. That's what that means. Or, you know, relative y value would be 6. And this one would be -6. So you might just see it written like that. They might also add on this. At x equals, I wrote over it, what is it, 1? -1. At x equals -1. Or you could even use the at symbol. Ooh, at x equals 2. So it's kind of a fancy way of writing an ordered pair, right? It's taking it out of the order that we normally see in our ordered pair of x, y. And you can see it all 3 ways. Just like the green and the red together, or just that purple, like an ordered pair. There's not really a wrong way. It just depends. So just be comfortable seeing it any of those ways. A big takeaway from this is that these are your y values right here. How high, how low did we go? Okay? Good? All right. I'm going to teach you guys how to do something on your calculator. For the sake of time, please do this with me. If you aren't paying attention, you're going to slow everybody down. Okay? So what we're going to do first is cross that bad boy out. I don't like it. And write a new one. Okay, so change to that. And we're going to clear the RAM on our calculator. Everybody before you has been using these calculators and changing it and typing lots of stuff in it. You should probably learn to memorize this after you memorize how to clear the RAM. But if you're ever at home or you're busy, if you don't remember, it's on your calculator tip sheet at the bottom, okay? And in fact, on this calculator tip pink sheet that you should have in your binder and your 3 rings, everything I'm about to go over is written out in step-by-step directions on that sheet too. So I'm going to give it to you verbally. I made a video just of me doing the calculator steps, just of that. It's on Fridays in modules for Friday's video. It says it. I went over all the calculator steps for 1 point. It's like this long explanation. You can't miss it. So if you just wanted to zero in on more help on the calculator, there's a video. So you've got the pink sheet, the video from Friday, the video right now, okay, lots of different ways of seeing it. All right, so go ahead and clear your RAM. So that's important. It's like having a fresh piece of graph paper put in front of you. Nobody's messed with it yet. You get to do what you want on it. And then we're going to type this function into the calculator. We are going to go to y equals and type that in. So y equals is right here, and I'm going to start typing. 2x is next to alpha. We should know by now where our power key is, right here. And it's a 3. Now, some of your screens look just like this. Some of yours don't. So if yours looks like mine, your cursor is up in the air, I call it. We need it back down on the ground. You just hit your right arrow, and it'll bring it down. You have to do that. If your cursor wasn't in the air, nothing's wrong with your calculator. It put the 2 right next, or the 3 right next to the x. It's fine, okay? You just don't have to bring it back down. It's all in a line, but it's still the same thing. Okay, so don't stress about that. 3x to the power of 2. I have to arrow out. Everyone should be typing this. Minus 3x plus 2. So get that typed in. Come on, guys. Type it in, type it in. When it comes time for the test, I'm not going to teach you how to do this. The stuff I'll help you with your calculator is like, I can't get out of this screen, or why does it look like this? I'm not going to give you the steps. You have to know how to do this, so you should be practicing with me. So once you get it typed in there, you can hit graph. And so you can see there's what that graph is, right? It's a rough picture, so we're just going to sketch it. Not perfect. Sketch means just rough, okay? So I kind of like identify, I've got a couple x-intercepts, also known as zeros, and I've got a y-intercept, and then I'm just going to kind of just, I don't know why I keep saying kind of. Beautiful. So that's a rough picture of that. Fine. And what we're going to do is use the calculator to find the max and the min. We don't know what those points are. The calculator is going to tell us. So I call this like an unfriendly graph. We have to rely on the calculator, and we're going to get some decimal answers, yucky decimal answers, but we can handle it, okay? So once we're at the graph, here's where you're going to go. And all of these directions are printed on that pink sheet. Second, you're going to hit your second button and go to Calc. And it's going to pull up a menu for you. And if you look, there's zeros, which we're going to do in a minute, min and max. And the first thing it's asking for is max. So I'm going to either arrow to number 4, or you can just hit 4, and it'll give you something that looks like this. So this is where you have to listen. We know, just by looking at this picture, there's a maximum here, right? So I can see where it is on here, too. What you see down here is left bound, okay? And it gives you an x equals 0, y equals 2. So it's telling you where your cursor is now. It's at 0, 2. So left to right, 0, up 2. I need to get to the left of the maximum. So this is kind of confusing at first, but after you do it a few times, I see how fast you guys can text, you'll be able to do this really easily. So I just arrow. Just take my left button, and you can see, it's moving the cursor along the curve. I need to be to the left of the maximum. I'm at the left now. This would be a good spot. This would be okay. This would be okay. It doesn't mean an exact point. It's just to the left of it. So I like to be closer to it, just less button pushing. Once you get your cursor where you're happy, like right now it's to the left of it, I hit enter. So it's like left bound, yes, we're good with that. See, we have right bound now. I'm going to right arrow to the right of that. I'm to the right of it now. I could hit enter now. I could go a little bit further if I want to. It doesn't matter. Just get to the right of it, hit enter again. And then it should say yes. You say yes, meaning enter. You don't press anything else. So it was left bound, enter, right bound, enter, and then yes, enter. And it's going to give us, you see where the cursor is? It's at that maximum. And it's telling us what the x and y value are. Like I said, it's yucky decimals. We need to be able to round in this class correctly so we don't get that wrong. I'm going to write it this way. The max is at 2.598. That's the y value. And it's at x equals negative 0.366. And the reason I chose this method is just because in a minute I have to say where we increase and decrease on, so I want the x values. So this point, if you don't want to write this on your graph, you don't have to. I'm just making a point. We just found that ordered pair right there. Okay? Now we want to find the minimum over here. So how do you get back to that menu? Second calc. So at the trace button. Again, we're back to that same menu. We want the minimum. So we'll hit 3. You can either hit the 3 next to it or arrow to it. Okay? Same exact steps. We want to be to the left of it. So that looks good. I am to the left of my minimum. I'm going to hit enter. I want to go to the right of it. So I just arrow to the right of it. Yep. It doesn't have to be that exact spot. Somewhere to the right. Enter. Guess? Yes, please. We'd like you to guess for us. So I just hit enter, and there is my minimum. Okay, so that's negative 2.598 at x equals 1.366. That's what it says. So that's this point. All right? So that's how we do it on our calculator. It'll take some getting used to, and then you'll have it. All right, let's do this real fast. Increasing. So we know there's arrows here. That's from negative infinity to the first x value, right? Right to here. That's why I wanted to write that there. We have another one from here to here. So this is just more review, guys. 1.366, this x value, to positive infinity, right? And then we decrease in that middle section. Oops, sorry, 0.366 to 1.366, right? Right in here, that's where we are decreasing. Remember, I used the x values. So that's what we've learned before. The connection is this. Your extrema can be found at the, anybody know? At the what? What are they called? What are these called? Turning points. Yep. Okay, which we already talked about, but there was an example, right? So there's some homework problems where you have to find the relative max and min given this. So we'll be going through those steps again, right? I'm just going to do part A in this next section because it's just how to find the zeros of a function, okay? Guys, zeros are x-intercepts, okay? Also called roots, also called x values, also called solutions. There's lots of words. So they're using the word zeros here for this point, this point, this point. And here's a function. So I can look at this graph and name them. I already know what they are, all right? It's negative 3, 0, and 4. But let me just show you, I won't do all of them, but let me just show you, and if you just want to watch for this one, I'm going to go back up to y equals and clear, because I have a new function. So I'm just going to type that in real quick. Why don't you just watch me? Because we'll do it in our homework in a second anyway. 0.15 x to the third minus 1.8 x squared. Okay, so I put the whole function in, and then I hit graph, and it should look like this if I typed it right. And it does. Now to find the zeros, I do the same exact thing. So watch. I'm going to go to second calc, and then go to 0, right? And it's going to ask me the same things, left bound, right bound, guess. We do the same thing. And we have to do it 3 times, potentially. In this graph we do. So just get used to it. It doesn't take long. You just arrow over to it. But I wanted to show this to you. Look, right now I am to the left of this side. We know when we go to the left, we're also above. It almost looks like it's going straight up, but it's not. It's just slightly going out. So just be careful just to understand that that is left bound. It looks like it's above, but it's also to the left. So that's a left bound. And then right bound, same thing. It looks like it's below. It is below, but it's also to the right. So I hit enter for my right bound and then enter for my guess. And you can see, there's my 0. At x is -3, y is 0, right? Because it's on the x-axis. And I kind of guessed that. Let me just show you one more. Let me do the 0 because the one at 0. Whenever your 0 is 0, it's going to give you an error. So watch. So if I go to second calc again to 0, right? So I need to go to the left of the middle one, this one right here. So I'm arrowing over to it and just get to where you're to the left of it. Hit enter. To the right of it, hit enter. Do I want you to guess? Yes, I do. And it's going to give me an error when it's done thinking. It's like, what is she doing? Why is she typing this in? And here's why. I mean, I don't really know why. I just know that whenever the 0 is 0, it's going to give me an error. But that's my confirmation that it is 0. Okay? Yes, it looks like 0, but we can't always go by what things look like. So by doing that, I found out that it is 0 because I got an error. Okay? And just so you know, if you did it again, you would get the 4. Okay? So that's something else you'll do is have to find the zeros. But they're all 3 the same. Zeros, mins, and maxes are all the same idea. You just have to know how to put it in your calculator. Okay? All right. We're getting there. Okay, stay with me. I know it's a lot of information. Remember we talked about absolute, min, and max and all of that? Well, this picture has those endpoints. This is a closed interval, meaning it doesn't have infinity symbols anywhere in it, right? It stops right here and it stops right here. No arrows, okay? Let's just pick out some important points. I think you guys would agree with me that that's a max. It's a relative max because it's in our relative viewing area, local. But it's also an absolute max, right? Because there's no points above it. On closed intervals, we already talked about at turning points, we have the mins and maxes. So we had some mins here. We didn't find them, but there's min here and a min here and a max here. We know that this is a max, right? Relative and absolute. But there's no other turning points, but endpoints can give us mins and maxes. So these are both minimums because they're at the bottom of the graph. They're both relative minimums because they're in our viewing area. Is one of them an absolute minimum? Yeah, this one, right? It's the lowest one. So this one is both absolute and relative. Just like this one was both absolute and relative. This one is just relative because there's somebody below it. Okay? So I just want to talk about that. All right, last example. Let's go through some of these quickly. This is where I'm really hoping you can understand the difference between local and absolute. Okay? We have 4 graphs on here. And I'm going to do this in a certain order for a reason. Notice all 4 graphs have arrows on the end. So these are all open intervals, meaning it goes on forever. It's not closed, it's open forever, okay? So all we have to worry about is our turning points. So looking at A, we know we have 2 turning points, so we have 2 extremas. Do we agree that this is a max and this is a min? Yeah. Do we agree that they're both relative? Yep. Are either of them absolute? Nope. So we have a relative max. And let's just make this easy on ourselves. It's one of our ways of doing it. And just put the y value. Could you do an ordered pair? Yes. Could you say 5 at x equals 1? Yes. We're just making this nice and short. Because it's one of our different ways to do it. And we have a relative minimum at 1. And as you guys said, there's no absolute or global extrema. Okay? There's a reason I'm writing that. So I'm going to make a point when we're done with these 3, 4. Okay? Let's look at B. Find your turning points. There's one. There's one. There's one. So we have 3 extremas. The 2 that are higher are relative max. We'll come back to if either of them are absolutes. And then we have a relative mean. Okay? They're all relative. Are any of them absolutes? Yeah, this guy, the 8. Good. Yeah, he's also an absolute because he's the highest one. This one's not an absolute because those arrows go right by it. We're going to keep going. We'll leave you behind. Okay? So we have a max, a min. If you want to write all that part in there, you can, or you can just look at the picture. But we know that's an absolute and a relative at 8. What's this one? 0. Y value is 0 there. And our min is at -2. Right, so I guess I'll just write it. They were all relative, and the max, this one was also a absolute max. Okay. Two turning points. We have a relative max and a relative min. Remember, you can say local as well. I'm a creature of habit. So are either of them absolute? No. Arrows go past both of them. Okay? So we have a relative max and a relative min. That's 9. This is -11. And you guys just told me correctly, there's no absolute extrema. There's a point to this. One more and I'll finally get to it. Turning point here, here, here. The two lower ones would be considered relative mins, right? That would be a relative max. They're all relative. Are there any absolutes? Yeah, this guy, right? He is the lowest. We know those arrows going up are not going to turn around. End behavior doesn't do that. And this one's not absolute max because those arrows went by it. Okay? So we have a relative max at 1, a relative min at 0, and an absolute and relative min at -9. Right? Do we see those, guys? Make a connection here. When your end behavior goes two opposite ways, you'll never have absolute extrema. Think about why. Because you're always going to go up and down forever, past any points in your viewing area. So when you have opposite down, up, or up, down, we'll go into that more this week, those are considered odd degree polynomials, meaning x to the first, x to the third, x to the fifth. You'll never have any absolutes. Okay? These are considered even numbers. X to the second power. Think of a parabola. X to the second. X to the fourth. X to the 54th. X to the 1,000,000th. Whatever. If it's an even number, you will have an absolute in your picture. Okay? So that's just kind of for you to pick up on. We can make it a little bit faster. Now, we are not doing example 5, just so you know. But these are wonderful practice problems. So you'll see me write this in your notes. This is not an assignment. This is just, if you're like sitting at home, you're like, I just don't get this, let me try it. These are all graphing calculator problems. Putting it in, finding the mins and the maxes and all that stuff, just like we did a few minutes ago. And I put the key on Canvas. So if you wanted to practice some more, there's some good problems, but it's not something I'm assigning, okay? So just so you know. You'll see this in the homework as well. So let's find 1.4, practice set 1, and write the assignment down. And I'm going to kind of go through these problems and explain what we're doing. Thank you for being wonderful. I know this has been a lot of information thrown at you. So A12, 1 through 4. So 1 and 2 are friendly graphs. You don't need a graphing calculator. So I wouldn't do those first because you can do those easily at home or in 7th period. 3 and 4, though, find the zeros. So I showed you how to do that. State the x value of the max or min, and then state the y value. So these are the x's, these are the y values. Okay, so it's like an ordered pair. They separated them into 2 sections. That's all it is. So you go find your minimums, your maximums, and then it's just an ordered pair broken into 2. As long as you can find them, that's really all that matters. Okay, then 5 and 7, I assigned, those are graphing calculator. So 3, 4, 5, and 7 are graphing calculator. I would do those first. 6 and 8 I did not assign, but I wrote practice that's on Canvas if you wanted to practice with some more, okay? Not an assignment. And then at the very bottom, no graphing calculator necessary. It's using this graph and pulling information off of it, okay? So 13 through 18. So there are 4 graphing calculator problems. I would try and do them right now. And I'll do the first one with you guys if you want, just to kind of help you, remind you. Yeah. So I'm going to do number 3, all right? And I did these in the video from Friday. So my morning classes had a little bit of an advantage. They took their quiz on Thursday, so Friday I didn't want to go ahead. So we just learned how to do this in the calculator, and I did these in the video. Okay, that's there for Friday, so if you needed to go back and watch that, you can. But I'm going to do it with you guys if you want me to. Okay, so go to your y equals and clear it out. So that's 0.25 x to the 4th. Arrow over if you need to, and go ahead and type the whole thing in. You should be practicing this, not watching me. And we don't have to sketch the graph. We're just going to find some special information about it. So that's the graph of number 3. We want to find A, which are the zeros. So go ahead and round to 2 decimal places when we do this, because that's what the key did. So I'm going to go to second calc, number 2, which was zeros. And there's 3 of them. So I'm going to try and learn, it's just fast. I see how fast you guys can text. Just get good at maneuvering the buttons, and it doesn't take very long. So I'm left bound, enter, scroll over, right bound, yep, I'm at my right bound, right boundary, enter, guess, enter. So that's where I got negative 2.54, the first one. To save time, just trust me, this next one is 0. If I did this, I would get that error message. It's at 0. Now let's find the last one. Second calc, 0 again. That's what we're doing. Use your right arrow, and I'm going to move my cursor. You can hold it down, make it move a little faster. Okay, so I went too far. Let me just back up. There's left bound. It's underneath, but it's still to the left, okay? So it's below and to the left. So I'm at left bound, yes. Let me go to right bound, yes, enter, guess, enter. And that's how I got 3.54. Notice all the y values are 0 because I'm on the x-axis, right? Then let's find so this graph has 3 things going on. So second calc, let's go with minimum. So pay attention to what button you hit. I'm doing minimum. I just chose to do minimum. So it doesn't matter which one I do first, just for the sake of keeping track. I'm going to go over to this one and work left to right. So I'm left of the minimum, enter. Right of the minimum, enter. Guess, yes. So it asks for the x values. Part B is the x value. So that's where I got negative 1.78. Trust me, there's a 0. Second calc. There's another minimum. Or I could have done the maximum next. It doesn't matter. Enter. So if you practice it a few times, you can get really fast at it. I'm kind of holding myself back from going fast so you guys can watch. But you can see I'm starting to go kind of fast. And then there's 2.53. So those were all the, that max was at 0. Sorry. So that was a max, right? So I didn't say that, but that was a max at 0. And what I should have done so don't make this mistake. I should have gone ahead and written the y values as I was doing it. So the y value, so just steal my answers. The y value for this one is right there. Right there. So I don't have to go back and type them in. Go ahead and steal my y values for those two. Yeah. There's a lot of different ways you could do it. So his question was, do you always write the y? Say, look, relative minimum and relative max, it was written as an ordered pair. I want you to get used to seeing it lots of different ways, because in a multiple choice, they could write it the way I did here, right, like that. They could write it as an ordered pair. They could do the way I did it here. There's 3 different ways. So if you do it differently than what it says in my notes, that's okay, all right? This one was just very specific. State the x value for B, and then the y value for C. So it's like the ordered pair here. So that one's kind of, these are kind of yucky, right? The whole key is on Canvas. If you're worried about your phone and forgetting it, I don't mind you getting it now. Sorry. It took really long. There's only like 2 more minutes in class. But remember, this is not going to be checked tomorrow. You have time. So when you get to class and you're waiting for me to start, you could be working on stuff like this. Come in during your lunch if you want to. If you want, not required. Thanks for being wonderful, guys. Yeah. Do you think the battery's died? Was it saying anything about that? Okay. Are you able to follow along?
Yeah.
Okay, I'm so sorry. Bye, guys. Bye, guys. You too. Sorry, it's such a tough day. Sometimes it happens. You too, sweetie.